Okay, so now this is the rules, and you're going to have to know these. And now, obviously, you can use these for when you do these predicting products. I mean, in years past, you study it and memorize it, and then you don't get the use of this on a test, but it is what it is. But it's fun. We got to learn this material. Okay. So decomposition is pretty easy if you understand how this works. It's easy if you know your polyatomic ions really well. So for example, decomposition, one complex substance in the reactant side of the equation breaks down into two or more simpler substances on the product side. And of course, conservation of mass, quantity of everything must be equal on both sides, and the type of the individual atoms. But of course, it goes through a chemical change to make something new. Okay. So what can we decompose? And I like to look at these first. I want to look at these examples. So let's see. Carbonates, when heated, it decomposes into carbon dioxide and oxide. Okay. There's one thing to memorize it. Well, let me tell you this. You're going to get something like this, calcium carbonate. And you know what the formula is right here. So if you were to break this apart, you would have calcium ions running around, right? And you'd also have carbon and oxygen atoms. What can you get out of that? Well, anytime you decompose a carbonate, you're going to get an ionic compound because you have a metal, and you've got a nonmetal here, an oxygen, calcium oxide. What's left over? CO2. Okay, so anytime you decompose something that has a carbonate CO3 2- polyatomic ion in it, you're going to get carbon dioxide and a salt, the metal nonmetal oxide. The nonmetal is going to be oxide. The metal is going to be whatever's there from before. Okay, so take a look at aluminum carbonate. Al2, you know the formula. Break it apart. CO2 is what you always get with a metal, aluminum oxide. Very simple. Okay, and it makes sense too. I mean, over here, you've got carbon here, you got carbon there, right? You got oxygen here, you got oxygen there, and it's over there too. You got the metal here, you got the metal there. Enough said. Okay, simple stuff. Because again, would aluminum rather be by itself, or would it rather be bonded to some oxygens to get that full outer shell? Obviously, it's going to want to bond with oxygen to get that full outer shell. Because some kids might ask, well, what if you get CO2 and then some diatomic oxygen, and then you get aluminum by itself? Well, if you've got aluminum there, it's going to go with the oxygen. Okay, so that's the carbonate polyatomic ion. Let's take a look at the chlorates. So any ionic compound where you have a metal, potassium, aluminum, whatever, and you've got the chlorate polyatomic ion. You know the chlorate is ClO3 negative. So that's why you see KClO3, and then Al parentheses ClO3, 3. How did it get 3? Because it took 3 of the negative ones to equal out the positive 3. That's why we really push the nomenclature. So let's see, what can we break out of this? Well, up here we could get carbon dioxide and metal nonmetal. What can I get here? It's a chlorate. So first off, do I have carbon here? No. So I can't get carbon dioxide, but I got oxygen. So I can get diatomic oxygen. That's going to be big. Diatomic oxygen is going to be big. Plus the salt, potassium chloride, the metal, nonmetal, potassium chloride. So the oxygen is taken care of, but the metal, nonmetal over here, the ionic compound. Take a look here, aluminum chlorate. Again, break it apart. You always get diatomic oxygen. What are you left with? Metal, nonmetal, aluminum chloride. Done. Very simple. So once again, here you get carbon dioxide with the decomposition of carbonate, metal, nonmetal, salt, ionic compound. Here we go again. Decompose the chlorate. What do you get? Metal, nonmetal, well, chloride, right? And oxygen. What about hydroxides? What do you see in here? You got some H and O in there, so you're thinking some water could form. Absolutely. With what's left over, metal, nonmetal. So again, when you react this, you get water and metal oxide, ionic compound. See how that works? Here, same thing, sodium hydroxide. Is sodium going to go by itself? No. Would iron be by itself? It could, but if there's oxygen there to accompany it, it would rather have a full outer shell. Do you see what I mean? So here, look, break it apart. You've got water. Well, but here's the question you get. There's only an H, one H here and an O here. Well, I have two H's here. Well, dude, look at the balanced equation there, genius. 2 hydrogens, right? 2 oxygens, 2 oxygens. See how that works right there? So you get water and sodium oxide. So again, so we go, the common factor here so far we've seen is an ionic compound, salt, metal, non-metal, in all three. And either for the decomposition of a carbonate, carbon dioxide, decomposition of a chlorate, well, there ain't no oxygen left over. I mean, what I mean by that is it's the decomposition of chlorate, ClO3, you have that oxygen, excuse me, there's oxygen left over. And here, decomposition of a hydroxide, water. What about acids? Okay, let's decompose sulfuric acid. You know that formula. So now when you decompose an acid, you always get water as one of your components. And what's the remaining thing? A covalent compound, sulfur trioxide, carbon dioxide. See the difference right there? So when you have this acid right here, see, do you notice here, are there any metals here? No. Are there any metals here? No. So you still get that common thing like water, right? And then what's left over? I have to do something with this sulfur. What's going to go with? Hydrogen or oxygen more so. It's going to go with the oxygen. Okay, so then you're going to have sulfur trioxide. Your carbonic acid, you should know how to name that. Very simple. You've got water, and you've got the remainder carbon dioxide. Very simple stuff. Okay, so far so good. All right, so now let's move on to the next part. Here we go. Let's go down to the oxides. When we say oxides, ionic compound that end in oxide. So right here I've got lead 2 oxide. EOA, PBO. Break it apart. What do we get? Oxygen, but it can't be its own individual atom. It's an active non-metal. It has to form a diatomic. It's one of those Brinkelhoff elements. You got to be careful there. And what's left over? Well, since the oxygens would rather bond with themselves to get that full outer shell, lead, since it's a transition metal, can exist by itself. See how you get that there. Same thing with mercury 2 oxide. Again, decomposed, but what's out there? Crazy oxygen atoms in chill transition metal. Well, the crazy oxygen atoms are going to find themselves. What's left over? Magnesium that can sustain by themselves, okay? Because they aren't that active. Well, what's this? Electrolysis. Okay, here we go with our words here. Electro means electricity, okay? Lysis doesn't mean what crawls around your head. Ew, nasty. Ew, hold on. Just kidding. Lysis means to cut or break. Lysis means break. Break what? Chemical bonds. With what? Energy. Electrolysis. Energy. Okay? Electricity. So right here you've got magnesium chloride. Bring that sucker right through. Right? Electricity. What do you get? Magnesium by itself, which is surprising because you'd think it couldn't be by itself, but chlorine is going to be with itself. Magnesium is going to be unstable by itself because of that energy. It took a lot of energy to break that apart and form that. Okay, it's fine. You had to add a lot of electricity to get that to break. Same thing here. The lithium metal is by itself, but they can't react with themselves because they both want to lose one. So some of it will revert back, obviously, but then you're going to have diatomic fluorine. You see how that works right there because they both want to gain one. Okay, so that's the first video. So now you have an understanding how to use it. Now you can use this. You have to use it. But eventually, as you practice more, I want you to try to do more on your own in your head and think it through. But this is the kind of way to help you think it through. Okay, so we're going to stop the video, and we're going to make another video on actually doing some of these for you guys. And you guys are doing a great job.